Confirmation of China's super heavy transport aircraft development. Payload breaks 120 tons, maximum takeoff weight hits 470 tons. Can it fly non-stop from Beijing to Hawaii? Are current US and Russian transports now a full generation behind? China's aviation industry has achieved another historic breakthrough. Can you believe it? In the field of strategic airlift, human aviation history is being rewritten by China. This new transport aircraft, just exposed by US media, can only be described as an aerial strategic behemoth. It possesses a gigantic steel belly capable of effortlessly carrying a 120-ton main battle tank and has an empty weight 88 tons heavier than the largest currently active U.S. transport aircraft, the C-5M Galaxy. The sheer size of its airframe makes it look like a mobile aerial fortress. This milestone achievement is the result of the painstaking decade-long effort by Academician Tang Zhenghong's team. As a leading figure in China's aerospace field, Tang Zhenghong led a research team with an average age of 35 to overcome over 200 technical challenges, including the super-heavy airframe structure and a composite power system. The most revolutionary feature is that this steel beast is equipped with the world's first composite stealth system. By integrating bionic skin with plasma generators, its radar cross-section, RCS, is compressed to that of a drone. Combined with its silent turbofan engines, it can penetrate the Asia-Pacific airspace virtually undetected. Even more shocking is its strategic projection capability. Relying on the Beidou satellite network for command and navigation, it can traverse 12,000 kilometers within 72 hours to accurately deploy 5 fully equipped heavy-duty battalions, including main battle tanks and self-propelled artillery, to any global battlefield. This technical breakthrough not only shatters the U.S. military's half-century monopoly on strategic airlift, but also heralds a revolutionary change in the future of warfare. The secret of the generational leap, its secret lies in the blended wing body, BWB, design combined with an advanced vertical tail system. This design essentially welds the aircraft's wings and fuselage into a seamless, streamlined loaf. Compared to the traditional tube with wings attached design of conventional transports, this allows it to carry 40% more cargo and saves 15% on engine fuel, a leap in efficiency comparable to upgrading a freight truck to a high-speed, fuel-efficient train. Even more groundbreaking is its short takeoff and landing, STOL, capability. While traditional strategic transports like the C-5M still rely on 3,000-meter-long concrete runways for heavy-load takeoffs, this aerial behemoth requires only a 2,600-meter short runway to lift off while fully loaded with tens of tons of material. Its unique vector thrust nozzle technology and composite lift system allow it to take off and land freely in the thin air of high-altitude airfields, on temporarily laid field runways, and even on damaged runways shattered by war. Most astonishing is its superior stealth performance. The streamlined fuselage is covered with a new type of radar-absorbing composite material, which, when combined with an intelligent electronic countermeasures system, renders the U.S. military's $3.60 trillion missile defense network useless. As this stealth Hercules streaks across the night sky, it appears only as a fleeting, faint dot on the radar screen. By the time the anti-missile system completes target lock, the aircraft has already traversed thousands of kilometers, accurately delivering strategic supplies to the designated area. This is not merely an oversized aircraft, but a heavy asset that rewrites the global strategic rulebook. Let's thoroughly analyze its technological prowess and see why its European and American counterparts are collectively panicking. China-US-Russia giant bird showdown. The new model, dubbed the aerial juggernaut by foreign media, directly crushes the competition with a maximum takeoff weight, MTOW, of 468 tons, surpassing the US C-5M's 380 tons and weighing 63 tons more than Russia's An-124. While its 120-ton payload may seem 30 tons less than the An-124's, its fully loaded range of 6,500 kilometers can cover the entire Indian Ocean without refueling. In contrast, the C-5M's fully fueled payload is only 130 tons, and its range is 500 kilometers shorter. The most critical advantage is its stealth capability. While US and Russian transport aircraft are all large radar targets, China's aircraft can fly along the very edge of the battlefield, potentially rendering the US military's entire Asia-Pacific radar network obsolete. Commentary: this is not a simple parameter lead, it is a generational leap. Looking back at aviation history, the An-124 and C-5 non-stealth giants, which the US and Russia spent half a century perfecting, long dominated the strategic transport sector with their immense payload and range. However, with modern air defense systems becoming increasingly sophisticated, these aerial behemoths are little more than moving, sitting ducks once they enter an operational area, making their survivability questionable. The Chinese research team took an unconventional path, achieving a breakthrough by perfectly integrating the seemingly contradictory attributes of a payload king and a stealth assassin through the world's first aerodynamic layout and application of stealth materials. Traditional strategic transports were limited by technological bottlenecks, adhering to the design iron rule: either large capacity or maneuverability. China's innovative design utilized BWB technology to reduce the radar cross-section, employed intelligent skin materials to absorb radar waves, and optimized the internal cargo bay structure. This achieved outstanding stealth performance and battlefield survivability while maintaining a super-heavy payload capacity. This epoch-making achievement directly breaks the technological path followed by Europe and the US for decades, officially ushering the global strategic transport aircraft sector into the new era of stealth heavy lift. Europe's A400M, the alliance that failed. In contrast, Europe's jointly developed A400M transport aircraft is currently facing a production crisis. This aircraft, once touted as the pride of European defense, has crashed repeatedly due to engine failures and fuselage rust, leading France and Spain to directly slash 23 orders. Even more ironic is that it was intended to replace the aging C-130, yet its price is double that of the C-130J, and its R&D costs soared from €20 billion to over €40 billion. The UK simply switched to buying the US C-17, and Germany also secretly made supplementary purchases of the C-130J, making the supposed European autonomy a joke. As the metallic screeching of the A400M echoed across European skies, this two-decade-long aviation gamble finally exposed its disastrous reality. As the project of the century for European aviation integration, the A400M adopted an unprecedented 9-nation division of labor model. France meticulously crafted the cockpit electronics, Germany built the precision tail structure, and Spain oversaw the wing engineering. Behind this seemingly powerful coalition, however, inconsistent quality standards among the various member states tore the project apart. A batch of landing gear caused a half-year shutdown at the French assembly line due to a German supplier's tolerance overruns, and when cracks appeared in the Spanish-manufactured wing skins, a second alternative manufacturer could not be found. In stark contrast, Academician Tang Zhenghong's team fought day and night in the Qinghai Tibet Plateau test sites and wind tunnel laboratories. They used independently developed titanium alloy 3D printing technology to break through the US technological blockade, compressing the production cycle for critical components from 18 months to 45 days. Their unique distributed fly-by-wire flight control system allows the aircraft to maintain millimeter-level precision even in extreme weather conditions. In this cross-century aviation race, Europe's loose go-it-alone alliance ultimately lost to China's systematic innovation under the whole-nation system. While Brussels was still haggling over R&D funding, the invisible giant bird of the East had already burst through the clouds, announcing the dawn of a new aviation era with its roar. How terrifying is 72-hour projection power? The core of strategic projection is speed determines victory. During the Iraq War, the U.S. military used the C-5 and C-17 to project 5 divisions over 30 days. The new Chinese transport can project 5 heavy-duty battalions in 72 hours, a theoretical 10-fold increase in efficiency. Russia's use of the An-124 to deliver the S-400 to Syria set a speed record at the time, but without any stealth capability, it would likely be intercepted today. More critically, this aircraft can execute humanitarian relief. It carries more than the An-124 and flies faster than the C-17, making it an aerial emergency station when disaster strikes. While military projection capability often sparks many associations, in reality it is also a crucial force for safeguarding peace. This capacity not only allows for effective management of regional situations but also plays a key role in natural disaster relief and public health emergencies. There are significant differences in how different nations use military transport technology. Some countries use it as a tool for global expansion, while China consistently upholds the concept of cooperation and win-win, employing advanced technology to maintain regional security and stability. Faced with some baseless international accusations, it might be better to objectively examine the true intentions and practical differences in the application of military technology by various countries.